Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we are following our pattern wise DSA sheet, and in this we are doing binary search. Following the pattern called binary search on answer, today we will solve the last question from this pattern, which is a split array largest sum. So let's read the problem statement. It is saying we will be given an integer array and an integer k. We have to split the array into k groups, non-empty subarrays. Okay, subarrays means we have to take the consecutive numbers. We cannot take from anywhere. We have to return the minimized largest sum of the split. Okay, minimized largest sum. Okay. A subarray is a continuous subarray. We know the definition. Now let's read the constraint. It says the num's length will be 10 power 3000 and nums of I can go till 10 power 6. Okay, so if you will do this in nested order, definitely 10 power 6 and 10 power 3 will become 10 power 9, and brute force code will give you TLE, because we know beyond 10 power 8 it gives us TLE. So hence we need to optimize. But let's do the brute force code first. Here the question says, here we have been given the nums array and we have to divide this in two groups. Okay, so let's divide this in two groups such that none of the group will be empty. So in the first group you will put 7, in the another group you will put 2, 5, 10 and 8. Okay, in first group you will put 7, 2, and second group you will put 5, 10 and 8. Yes. Now in the third group you will put 7, 2 and 5, and now next time 10 and 8. Yes. Now next time 7, 2, 5 and 10, next time 8. Now let's do the summation first. Total summation is 7 plus 7 14 and 10 24 and 8 32. So this is the 7. So definitely the leftover will be 32 minus 7, which is 25. Okay. So in this case what is maximum, 7 or 25? Definitely 25. Okay. Now the second case, if this is 9, so 32 minus 9 is nothing but 23. So this much summation will be 23. So what is maximum? 9 is maximum or 23? Definitely 23. Okay. Now in this part, 7 plus 2, 9 plus 5, 14 and 18. So what is maximum? Definitely 18. Okay. And in this part, if one is 8, so next one is 32. So definitely it will be 24. Okay. So 24 is the maximum. So out of all this, what is the minimum summation? If you see, 18 is my minimum summation, and that's what expected output also. But how did I find this? Question says minimize the maximum summation. So basically you have to divide it into two parts, and whatever will be the summation of these two parts, now out of this you have to take the maximum. And hence 18 will be our answer out of all, because that is what minimize the maximum one. So what we will do, let's see what can be our maximum possible answer here and what can be our minimum possible answer. Because in the constraint it says ki k can be 1 also. So let's suppose here, if instead of k 2, k was 1. So definitely you will put everything in the same subarray. So what will be the final answer in that case? That is nothing but summation of whole nums. When k will increase, now you have to divide this into groups, and now your final answer will decrease from a higher, which is summation of all, to some lower value. So what will be the higher value here? That is nothing but what? Summation of all. So high value is nothing but summation of all, means 32. Now let's see what will be the lower value in this case. You remember these four patterns? Okay, so here we have got 18 as a final answer. So if you will see the minimum out of all, definitely you will say ki 8 can be my minimum or else 7 can be my minimum. But suppose the arrangement was such that 8 here and 10 here, correct? So definitely you will collect all this in one group and this 10 in another group. So what is the minimum possible answer? 10. Why not 7? Because when you will take 7 now, question is focusing to increase it as much as possible. So if you are focusing on the maximum one, that you have to minimize, and if you are focusing for the lower constraint, if you are focusing on the minimum one, that you have to maximize. So you can say na ki in one part let's take only one element. That can be your 7 also, that can be your 8 also, but what is the maximum one out of all? 10, and leftover in the another group. So the similar part we have already discussed in the previous question called allocate minimum pages, and if you will read this, like we have already read the problem. So this problem is totally related with minimum number of pages. If you have not watched that video, I will definitely tag it somewhere and you can read that problem. Whole problem is just copy pasted. The only thing is ki problem statement changed, but the logic and total solution is as it is. here also you have to minimize the maximum one, and there also you have to minimize the maximum one. So I will definitely recommend you all to go and check the logic explanation, and here we will discuss the solution. So here is the Java code that is in brute force approach. So definitely we want a lower and higher value, and for the lower value we want the maximum one as said here, and higher value will be summation of all elements. Now the brute force approach says ki why not to run the for loop from a lower to higher value, and let's call a function. From there we'll get something, and if the function returns true, that we can save in an answer variable and break the loop, or else we can return this answer then and there. And we have already initialized this, or else if the function does not return suppose any such answer, so definitely at the end the higher value, which is nothing but the summation of all elements, that will be our final answer. Now in the function what we are doing, we are incrementing the count. There in the minimum number of pages, there we initialized a student variable, and there also we incremented, like initialized with 1. And in this we have run the for each loop, and one by one in the current sum, which is nothing but the running sum, there we will try adding, like taking this integer value, okay, and by taking that, if it is still less than equal to maximum sum, we can add that, or else we will increment the group saying ki now 7 and 2 only we want to keep in the first group, and 5 we cannot include. So now from 5 onwards we will make the another group. That's what we are doing, and we will increment the current running sum with num. Now guys, I am not going to tell ki why this, what is this maximum sum and what are we sending in the group, because we have already discussed everything in the previous problem, which is minimum pages. If you have not solved the problem, definitely that is very important problem, because both of these problems are similar. So I will definitely recommend you to check that, and trust me, if you'll do that, now this problem is as it is, you can do this on your own as well. And if in case you have already solved that, so totally you can relate with this solution. So now let's see the time complexity. Definitely the for loop, which is nothing but this one, line number 12, this is running from a lower value to higher value. So can I see the higher value is nothing but nums of I can go till 10 power 6. So I can say that this for loop is running till 10 power 6. Okay. Now the second for loop inside the function, we are running the for each loop, correct? So this is running till nums size, and num size is 10 power 3. So in total 10 power 6 into 10 power 3, so total 10 power 9, and definitely this will give us TLE. So what we can do, as we know this for loop, we are running from a lower range to a higher range, and it is already in a numbered line, so it is sorted. So we can apply the binary search logic here. So that's what we did here in the optimized code. We have only removed, like changed the for loop into a while loop running the binary search approach. From a lower value to higher value, we will calculate the mid, and we'll call the function with that mid. If it is possible, we will, as we want a minimum possible value, so we will go for a lower part, like left half array search, or else we will move towards a right half array search. Why? As said, already discussed in the previous problem. So I will request you all to do that problem if you are not able to understand this one. So now this we can submit, and this was your Java solution. As you can see, the time complexity will be logarithmic of 10 power 6 multiplied by 10 power 3. So this is the fastest solution. Here is your Python solution if in case you are from Python background, and here is your C++ solution if you are from C++ background. So with this we can go in our rising brain sheet, and we can mark the last question also done. So we are done with the binary search and answer pattern. If in case you have any doubt, do let me know in the comment section. And please do that previous problem, which is minimum page allocation, because this problem was totally related with that previous one. And that's it guys. If you like the video, if you understood from the video, please do hit the like button and subscribe the channel if you have not yet subscribed. And if in case you guys are new to the channel, we are following the pattern wise DSA sheet, and I will definitely recommend you all to check the free sheet link from the description. And if in case you want to connect with me on social medias, then all the links will be there in the description. So that's it for this video guys. Let's meet in another video with some more interesting topics and questions. Till then, keep learning, take care of yourself and your family.